Dear all, today I am going to explain about the coupling and isolation characteristics of microstrip directional coupler. The main aim of this experiment is to determine the coupling and isolating characteristics of microstrip directional coupler, and objective is to understand the coupling and isolation characteristics of directional coupler. And it is very much necessary to know what are the apparatuses required in this experiment. So we are using a microwave signal generator with modulation attenuator pad of 3 dB, and the microwave signal generator has a modulation range from 2.1 to 3 gigahertz, coaxial cable, VSWR meter, matched loads of 50 ohms, and directional coupler having an microstrip parallel coupled coupler also of 2 to 3 gigahertz, and connecting cables. And coming to the theory of the directional coupler, a directional coupler is a 4-port reciprocal plus passive network. The basic function of the coupler is to sample power flowing in one direction in a transmission line and reject the power flowing in the opposite direction. And this figure shows the schematic of directional coupler, which is having a primary waveguide as well as the secondary waveguide. So you can see over here the port 1 is used as an input port and port 2 is used as an direct output port, and port 3 is a coupled port and port 4 is an isolation port. The properties of an ideal directional coupler are all the terminations are matched to the ports. Once the power travels from port 1 to port 4 to 2, and the same portion of it gets coupled to port 3 but not port 4. So this is how it works, and as it is also a bidirectional coupler, when the power travels from port 2 to port 1, the same portion of it gets coupled to port 4 but not port 3. If the power is incident through port 4, okay, and a portion of it is coupled to port 2, but here but not the port 1, okay, and if the power is incident through port 3 and a portion of it is coupled to port 1 but not to port 2. So this is how it works. So ideally the output of the port 3 should be 0. So with this basics, so we can see that the practically a small amount of power will come back, and this power it is been observed at the port 4. And next, looking at the experimental setup of this directional coupler. So here we have to assemble the setup as shown in this figure. The signal generator with the source of 2.23 to 3 gigahertz with an 1 kilohertz amplitude modulated has to be connected to one end of the cable P and Q, and we have to set the frequency of this source to 2.3 gigahertz and increase the RF power output of the source till the VSWR meter shows the reading in the range 45 dB. Okay, once we start increasing the frequency of the source in a stepwise of 0.1 gigahertz, that is say from 2 to 3 gigahertz. So we have to note down the corresponding readings in the VSWR from the VSWR meter. So you can see over here. So in this meter we have to note down the corresponding coupling readings. Here two things we have to measure. One is the coupling characteristic and another one is the isolation characteristics. And first, to measure the coupling, we have to insert the parallel line coupler between the P and Q now. Okay. So with the port, that is input port is connected to the P and the output is connected to the port Q. and we have to terminate the port 2 and port 4 of the coupler. So with an 50 ohm matched load, and we have to record the readings of the VSWR meter for the frequencies which is mentioned, that is from 2.2 to 3 gigahertz. And using the calibration graph, we have to get the corrected values and we have to note down those values also, so that from the port 1 to port 3, so whatever the coupling can be calculated with the calibration graph. So from port 1 to port 3, what is the readings? So both we have to note down. And next thing is the isolation. To measure the isolation, now we have to connect the line coupler, that is between P and Q, with the port 1 which has an input port connected to the port P, and port 4 which is an isolation port to be connected to the Q. And now we have to change the switch the terminations, that is port 2 and the port 3 has to be terminated with an 50 ohm matched load. So with these readings, again the same way, by increasing the frequency of the source, so we have to note down the VSWR meter which has been already mentioned, that is from 2.2 to 3 gigahertz, and using the calibration graph have to note down the corrected values also, so that we can calculate the isolation from port 1 to port 4. So and with the help of the calibrated value, taking a minus value, so we can find out. And this is what the tabulation we can do over here. So we have to record the readings from 2.1 to 2.3 gigahertz, port 1 to port 3 to be measured the coupling, and we have to take a P1 dash and P3 dash, which is from the calibrated graph, and coupling is calculated with the subtracting the P1 dash to P1 to P3 dash, which gives you the coupling characteristics. And to measure the isolation characteristics, same way we have to record the frequencies and VSWR meter ranging from 2.1 to 2.8 gigahertz from port 1 to port 4. And using the calibrated graph, note down the P1 dash and P4 dash, and from the help of these corrected values, so we can find out the isolation characteristics. We can calculate the isolation characteristics by subtracting the P4 dash from P1 dash, so that P1 dash minus P4 dash gives you the isolation characteristics. Okay, so now this is the experiment on the microstrip directional coupler. So once we have completed this one, so that the student will learn how to understand the coupling and the isolation characteristics of the directional coupler. So now let us look at the experimental practical implementation or the demo, how it is been conducted. Okay, so here you can see we have a directional coupler, microstrip directional coupler. So this will helps us to find the coupling and the isolation characteristics. So this is the port 1 and port 2 and the port 3 and port 4, and now we have to measure the isolation characteristics. So this is what the detector we have, that is a load which is helped us to terminate it. So now to find out the isolation, that is the coupling. So first what I will do is that I will connect this port 2 with the terminate load, and the isolation port is also been terminated over here now. Okay, and we can measure the coupling, only the coupling characteristics, as we did in the ring resonator, same way, and the connections have to be made using the detector also. So this detector is connected to this port 3. So this is how the connections you can see over here using the detector, and once the connections are made like this, so we can increase or vary the frequency from 2 to 3 gigahertz and turn on the RF. Let us vary that frequency, and by varying the RF, so we can measure the readings in the VSWR So in the VSWR readings has to be noted down over here for the coupling of an to calculate the coupling characteristics. Okay, so now suppose if next is what the isolation characteristics. So in order to find out the isolation characteristics, so now we have to switch this detector to the opposite port. Okay, so and this port has to be terminated with a maximum load. So the both are being exchanged over here. We are exchanging those two now. Yes, once this is been done, so we can calculate the isolation characteristics also just by varying the frequency in the signal generator and note downing the and vary the RF. By varying the RF and the frequencies as mentioned, that is from 2.2 to 3 gigahertz, we have to note down the VSWR meter, tabulate it, and finally we can calculate the isolation characteristics also. So this is how the experiment is being conducted in the laboratory. Yeah, and this is about the calibration graph. So in the calibration graph, so whatever the range, whatever the VSWR value we have obtained, so that has to be noted down over this calibration graph exactly at the same point, and the corresponding corrected value from the graph is been tabulated, and by taking the difference of this calibrated value, then the whatever the readings we have got, okay, so we can calculate the isolation as well as the coupling characteristics of this experiment. So this is how the corresponding value we can take over this one, and this completes this experiment. Thank you.